Hi everyone, I am Pekcan Baycan and I am software engineering second year student. This is my tutorial about modern system analysis and design. Let's start with chapter 1. Learning objectives. Define information system analysis and design. Describe the different types of information systems. Describe the information system development lifecycle, SDLC. Explain rapid application development, prototyping, joint application development, and computer-aided software engineering. Describe agile methodologies and extreme programming. Explain object-oriented analysis and design and iterational unified process. Introduction. Information systems analysis and design. Complex organizational process used to develop and maintain computer-based information system used by a team of business and system professionals. A modern approach to system analysis and design. In 1950s, focus on efficient automation of existing process. In 1960s, advent of 3GL, faster and more reliable computers. In 1970s, system development becomes more like an engineering discipline. Continues, and 1980s, major breakthrough with 4GL case tools, object-oriented methods. In 1990s, focus on system integration, GUI applications, client-server platforms, internet. The new century, web application development, wireless PDAs, component-based applications. Application software, computer software designed to support organizational functions or process. System analyst is organizational role most responsible for analysis and design of information systems. Types of information system and system development. Transaction processing system, TPS. TPS is automated handling of data about business activities. Process orientation. Management information system, MIS. MIS is converts raw data from transaction processing system into meaningful form. Data orientation. Decision support system, DSS. Designed to help decision makers, provides interactive environment for decision making. Involves data warehouse, executive information systems, database, model-based, user dialogue. Summary of information system types. Transaction process system, IC characteristics, high volume data capture. Goal is efficiency of data movement and processing and interfacing different TPSs. For management information system, draws on diverse yet predictable data resources to aggregate and summarize data, may involve forecasting feature data from historical trends and business knowledge. For decision support systems, provides guidance identifying problems, finding and evaluating alternative solutions, and selecting or comparing alternatives. Potentially involves group of decision makers, often involves semi-structured problems and need to access data at different levels of detail. Developing information systems. System development methodology is a standard process followed in an organization to conduct all the steps necessary to analyze, design, implement, and maintain information systems. System development lifecycle, SDLC. Traditional methodology used to develop, maintain, and to replace information systems. Phases in SDLC: planning, analyze, design, implementation, and maintenance. System development lifecycle, SDLC. Planning is an organization total information system needs are identified, analyzed, prioritized, and arranged. Analyzed system requirements are studied and structured. Design is a description of the recommended solution is converted into logical and then physical system specifications. Logical design. All functional features of the system chosen for development in analyze are described independently of any computer platform. Physical design. The logical specifications of the system from logical design and transform it into technology-specific details from which all programming and system construction can be accomplished. Implementation. Implementation is the information system is coded, tested, installed, and supported in the organization. Maintenance. An information system is systematically repaired and improved. This is heart of system development process. It's about analyze, design, code, test. Traditional waterfall SDLC. You can see the graphic. Problems with waterfall approach. System requirements locked in after being determined and limited user involvement and too much focus on milestones, deadlines of SDLC phases to the detriment of sound development practices. Different approaches to improving development. Prototyping, computer-aided software engineering, case tools. Joint application design. Rapid application development, agile methodologies, extreme programming. Prototyping, iterative development process, requirements quickly converted to a working system. System is continually revised. Close collaboration between users and analysts. This is about prototyping graphic. Computer-aided software engineering. Diagramming tools enable graphical representation. Computer displays and report generators help prototype how systems look and feel. Analyze tools automatically check for consistency in diagrams, forms, and reports. Central repository for integrated storage of diagrams, reports, and project management specifications. Documentation generators standardize technical and user documentation. Code generators enable automatic generation of programs and database code directly from design documents, diagrams, forms, and reports. Joint application design. It's about structured process involving users, analysts, and managers. Several day intensive work group sessions. Purpose to specify or review system requirements. Methodology rapid application development. Methodology to radically decrease design and implementation time. Involves extensive user involvement prototyping, JAT decisions, integrated case tools, and code generators. Graphic about rapid application development, requirements planning, and user design, construction, and cutover. Agile methodologies, motivated by recognition of software development as fluid, unpredictable, and dynamic. 3K principles. First one, adaptive rather than predictive. Second one, emphasizing people rather than roles. Third one, self-adaptive processes. Extreme programming. Short incremental development cycles. Automate test. Two-person programming teams. Coding and testing operate together. Advantages. Communication between developers. High level of productivity. And the last one, high quality code. Object-oriented analysis and design. Based on objects rather than data or process. Object is structure encapsulating attributes and behaviors of real-world entity. Object class, a logical grouping of objects sharing the same attributes and behaviors. Inheritance, hierarchical arrangement of classes enable subclasses to inherit properties of superclasses. Rational unified process, an object-oriented systems development methodology. RUP establishes four phases of development: inception, elaboration, construction, and transition. Each phase is organized into the number of separate iterations. Our approach to system development. The SDLC is an organizing and guiding principle in this book. We may construct artificial boundaries or artificially separate activities and processes for learning purposes. Our intent is to help you understand all the pieces and how to assemble them. In this chapter, you learned how to First, define information systems analysis and design, and describe the different types of information system. Next one, describe the information systems development lifecycle (SDLC). Explain rapid application development, prototyping, joint application development, and computer-aided software engineering. Next one, describe agile methodology and extreme programming. Explain object-oriented analysis and design and the rational unified process. Thank you for watching. See you on next chapter.